Cheers. Thank you very much. So for this next bit, I'm going to keep the slides relatively slight because I'm sure that we're all aware of what a virtual machine is. You've probably used them enough times in your on-prem environments or at home in your home labs. So for those of you who might not know what a virtual machine is, think of it as it's just another instance of an operating system running on existing hardware. It's pretty much common practice now from the days of old where you'd have a rack of physical servers. You can now condense that rack into half of that size and then run multiple instances of operating systems within inside of each other. That said, I'm now going to cut over to give you guys a demo of deploying one into Azure. Oh, that's good. So as for those who were around in the last episode, Gregor did a short whistle-stop tour of the Azure portal. So this, for those who don't know, welcome to Azure. This is what you get when you log into the portal first time around. So this is, the overview once you've logged in. So what we're going to do conveniently, Lisa beforehand has created us some resource groups in here. So this is my resource group that we're going to use for the demonstration. So to create a resource, you click down on create resources. This then brings up a new window. And you can see that there's loads of resources here that we can pick. But for what we're going to do, we want a virtual machine. And then, as you can see here, there's loads of different versions, but the one we want is here, the virtual machine by Microsoft. And so here we go. So this gives us a breakdown of, similar to if you're used to building virtual machines inside of either Hyper-V or VMware. It's the same sort of principle. So you need to have the resource group, which we've already got created before us. And then you can just fill in all the details that you need. So for this example, we're going to deploy Windows VM. So we'll call this Windows 01. You can then pick and choose which region you want your machine to be deployed into. So because I'm based in the UK, I'm going to go for UK South. And as you can see here, it says that the recommended space is UK South. And if you hover over it, it'll usually give you a reason as to why. So it could be for capacity, or if you're wanting a larger SKU set of compute resource, this is where to go. So then next, I'm going to pick my Windows Server Data Center Edition. So an interesting thing to point out is that when you're deploying Windows Server into Azure, you can only go with the data center option. There is no standard, which obviously from a resource point, you obviously get all the features within the data center SKU for Windows Server. So we're going to pick this SKU size. Again, it'll give you a recommended with costings. So if I wanted to change this, you can see all the various different SKU sizes. So these are what are considered the general purpose, which are pretty smaller SKUs. But if you wanted to, and don't worry, Lisa, I won't deploy this into your subscription. You can go down for bigger.
Appreciate it, Simon. Thank you.
It's all right. So yeah, if you were wanting to deploy like an SQL database, for example, you can go down for the memory optimized, which give you lots and lots of memory, but then at the same time, it gives you a price to go with that. So as you asked me very nicely, Lisa, I will go for a B2 SKU, which gives us 2 virtual cores and 4 gigs in memory. And we only get 1,280 IOPS for this SKU. So if you're wanting to run an application or a workload that's really IOPS intensive, this is something to take into account. And if you need more than that, you then need to scale up the SKU to a higher SKU. So once we've selected our SKU size, we can then create our username and password. So we'll just call this Windows admin and then create a password against it. There we go. So we've got a password. Obviously, this by default, as we've already advised, this is obviously a really bad idea. So I would recommend that if you are going to expose 3389 or RDP to the world, please either put it behind a VPN or lock it down to just source IP addresses so you know who's connecting
By the way, Simon, I heard this story about this guy doing a workshop, and he deployed a virtual machine, and he was real-time hacked within the time of his session.
Yeah.
And he got all of the resources deleted. So I would say, yeah, if you deploy a virtual machine, make sure to think about the security. Yeah.
Exactly. So taking that,
just for the record, it wasn't me.
No,
it wasn't anyone here, and I don't want to point fingers, but yeah, that's how quickly it can happen. I was really surprised by it myself, but yeah.
So taking that brilliant point into account, Lisa, for now we're going to not allow any outbound ports, which obviously, because this is currently public facing in terms of all being in Azure, and we don't have a site-to-site VPN. Once we've deployed this, we won't be able to connect to it, but that's fine because I'm sure you're all used to seeing what the inside of Windows Server looks like. So we're just going to cover the deployment stage in Azure. So next, you move on to your disk deployment. By standard, it'll give you premium SSDs. If it's a test dev machine, you could drop that down. It'll save you a little bit of money, but obviously with saving the money, you get the compromise on performance and speed. If you then want extra data disks for your application, you can create them in here. And then you get a SKU size that you can pick and choose from. One thing that I learned out relatively young when I was getting used to my Azure life is you can't downsize disks. So if you upgrade a disk by accident, you are committed to that disk space. You cannot resize it. The only way that you can resize that disk is to create another smaller disk and then migrate the workloads over. And so once you've upsized the disk, that's it. You're committed. There is no going back. But for the demo that we're doing, we don't need any additional disks. Then next, we get to networking. So if you've not deployed any virtual networks previously, it will automatically assign one. So it'll give us the virtual network name. It will give us the subnet that it will deploy the virtual machine into. It'll then give us a public IP address if we need one. It'll then create a network security group and then ask us if we want any external ports or services exposed. From a management point, it's always useful to tick this option here to delete the public IP address in the NIC. So when you're then cleaning up your resources, once you're finished with the lab environment, instead of you having to go through and individually find them, when you come to delete that virtual machine, it'll go, oh yes, you tick this box. So when you want me to tidy this up, we will go through and remove all of this. Again, we don't need load balancing for this example. So then for management, if you wanted to log in with your Azure AD credentials, you can enable this. Bearing in mind that for this option to work, your local client machine needs to be enrolled into your Azure AD environment. We found this out with a couple of customers where they had contractors coming in trying to use Azure AD credentials and found that actually because their machines were registered to the contractor's company, they weren't able to use this. So we ended up having to create local accounts. So just be aware of that if you get caught out by it. Again, from a cost saving perspective, you can auto shut down machines. And this basically says that at 7 p.m. it will then auto shut down. And then if you want to configure backup, you can do it from here, or we can do it. We'll probably cover that later on when we get to the recovery services vault bit. And then same for patching. You can either choose to have it done by yourself or let Windows do it automatically for you. Then for monitoring, if you want to enable any alerts for if you get any CPU spikes, that's really useful. Boot diagnostics is really useful. It basically gives you a screenshot of what's happening inside of the OS. So if you have an issue, or if it falls over, or if it's blue screen, for example, and you can't get any live or connectivity out of your virtual machine, going to the boot diagnostics tab is always really useful, and it gives you a point in time screenshot of what's happened locally. So again, for the advanced tab, so there's extensions which won't be covered for the AZ-900 exam. It allows you to do some more interesting stuff in terms of like post configuration. So you can use it to deploy antivirus or extra logging, or if you've got third-party applications that need to be able to speak to or interact with the virtual machine, you can add them there. And then finally, when we get to the tagging stage, which I know we've spoken about before, which ties back into some of the management SKU stuff that Lisa was talking about. If you've got certain environments or departments that you either want to bill against or want to monitor on, you can tag them here. So if you've got a development team, for example, that that are only allowed to access this machine, or that you need to build back to a certain cost center. You could create a tag, and then you can create a report, which you can then send off to the finance team to say, hey, this machine was used so many hours this month, and this is how much it's going to cost them.
So Simon, can I ask you a question? So I think a lot of people have already used VMs, but for the people that might be watching this back and that are really, really new to Azure and have never seen a VM at all, like for what kind of customers do you deploy virtual machines on a daily basis?
It varies. So obviously virtual machines, in terms of what you can do in Azure, virtual machines, it's all very, I don't want to say old school, but in terms of like the services that Azure can provide, it's an old school technology. As those who manage current VM estates, it's a hassle. You have to look after them. When they go wrong, it takes ages to get them patched and back up, and you have to make sure that they're all backed up. And when there's a vulnerability found, you have to go and do remediation work, and there's extra security issues around having VMs from other people being able to access them.
Yeah.
So we're seeing less and less people use traditional VMs. Obviously, when we come to talking about like Kubernetes and AKS, under the hood, that still uses VMs, but you don't see that part of the management plane. That's all managed for you by Microsoft behind the scenes, and you then just deploy your containers and your workloads within that. So it makes your life a lot easier.
It's the same with data resources like Databricks, Data Factory, and even Synapse Analytics. Like if you get computational power, then under the hood, they just spin up a virtual machine. So that's how they do it. Yeah.
Yeah.
Cool. Thank you.
No worries. So with that said, we have completed all our pre-flight checks. We've passed all the validation. So this is basically a quick overview to say what we're going to deploy and everything that we've agreed on. And then you just hit create. So we can then see this is now deploying the resource. So this is now deploying our virtual machine into a rack somewhere in the UK South data center. And depending on how many requests have gone in while we were talking about this, sometimes it can be a couple of minutes, or sometimes it can take 10 to 15 to 20 minutes, depending on how many other requests are in front of ours.
How long does it usually take to deploy Azure resources in general? Do you know?
It depends. It's how long is a piece of string. So if you're deploying like a VPN gateway, for example, it can be anywhere from I've seen it take from 45 minutes to 2 hours. Deploying VMs and storage accounts and things are usually pretty quick. Deploying an AKS cluster is not too bad, but sometimes you can just not have the Azure gods with you, and it can just take forever. I know Gregor can tell you some stories of trying to deploy things through infrastructure as code and trying to deploy like application gateways and front door, and the hours he spent waiting for the portal to just do its stuff.
VMs are usually quite quick. Some other services take a lot longer for obvious reasons, but some of them can take a while. Most of them are quite quick. If you want to play about with things quickly, VMs and storage accounts are probably your go-to for deploying stuff quickly.
So as you can see here, Lisa, this is it done. We've deployed our virtual machine, so we can go to the resource.
Wow.
Yep. So this is the overview that gives you. So it gives us a basic breakdown of the computer name, what operating system it's running, whether it's 32 or 64-bit, the SKU of the machine, and then disks. So to just give you a brief overview, because from the exam perspective, I think when I sat it, granted it was a year and a bit ago now, it was more than the questions I got were more around, I have a workload which is X. What would you recommend I deploy it into? So you don't need to know a huge amount of the ins and outs of how everything hangs together as a virtual machine in Azure. You just need to know what it is and what it can support. I have a question from Carl here. So he says, if we have time, you said it's not possible to downgrade the storage. So you can downgrade the the virtual machine SKU size. So if we go to sizes, so you can obviously do this one of two ways. From a production environment, I would obviously recommend you shut down the resource first. If it's in a test and dev environment, if we wanted to scale up, so as you can see here at the moment, we've got a standard B2. If we wanted to downscale this to a B1, I can select the B1, which then gives us only one virtual CPU and 1 gig of memory. If I hit this, it will automatically start the scale down process. So it will reboot the VM while live. So you want to make sure that obviously there's no customer workload running on that at the time, and then change the SKU to be 1 core and 1 gig of memory. Does that kind of answer your question, Carl? Or are you wanting some more detail? Cool, great. So I think, the only thing to just mention is the boot diagnostics that I said. This is really useful when you're trying to troubleshoot inside of Azure. I spend so many hours looking at this when I lose a virtual machine, or if it's had a bad update and it's stuck on Windows updates, you will usually get a very black screen in here or a green screen with a spinning Windows update. And that's when you know that, okay, it's hung rebooting or updating or whatever. So then you just scroll back up to the overview page, and then you can just hit restart. So yeah, that's in a nutshell how you deploy a virtual machine into Azure. Can we jump back to the slides, Greg?
Yeah, let me try and see if I can still work this. Hopefully this works out. Cross your fingers. Look all right now?
I can see us too. Oh, give it a second. Cool, great. Yeah, so we've done that. So can we hop to the next slide? So yeah, this one, great. So yeah, as we've already covered, virtual machines, they're great in terms of everyone knows how they work. Everyone was brought up with them. That's fine and dandy, but there are other options that you can use. So containers are obviously a much nicer way if your application supports it. The way it was explained to me how you should treat containers is they're like cattle. VMs, with virtual machines, you spend a lot of time with them, you become friends with them, you look after them, you learn the quirks of the applications that run in them, and you end up with lots of like notes on how to fix this when this part of the application falls over. With containers, it's slightly more less friendly. So if you have a problem with the container, you can basically destroy that container and it will automatically rebuild, and you can use pipelines to then inject your application processes back into it. So from a turnaround perspective, it's a lot quicker. For functions, they are great for certain workloads. So for Gregor, by all means, correct me if I'm wrong here, but a standard function that runs in Azure has a life cycle of about, is it 5 minutes?
Yeah, 5 minutes. Yeah, you can get it up to 10. 10's the max, but it's normally 5.
Sure. So an out-of-box function will run for 5 minutes. If you have, for example, a workload or something that needs to be longer, you then have to use a premium SKU, which with everything in Azure comes with a price. So you have to put a premium app SKU in, and then you can run that workload for longer. And there's various types of functions that you can run, but the most common are probably either time-based or HTTP-based. So you can use it as like an API query hit point. So if you see something, you can then trigger that from there. Cool. Can I have the next slide, please? So again, this part of virtual machine scale sets and availability sets, this also is relevant for AKS as well. So AKS, for those that don't know, is Kubernetes, which is run in Azure. So it stands for Azure Kubernetes Services, which we'll cover in a minute or two. So for a VM scale set, what that basically does is it takes your virtual machine and it creates 3 instances. So within the same rack in the data center. So if one of those racks has a problem, whether it's a hardware issue or a disk failure, your application will still run because it's contained within a scale set. And then an availability set is similar to how a scale set works, but it's based on data centers within the region. So if you have a regional outage, your application will still run.
So Simon, can I ask a question real quick about this? So with the scale sets and the availability sets, does that also mean they're more expensive than just a regular virtual machine?
Nope.
No.
It's kind of like a DR scenario. So if you have, for example, the standard B2S that we just deployed, you can put that into availability set at no extra cost.
Okay, cool.
But you do pay per instance that's running. So if you have an availability set with a VM in each availability zone, you're paying for 3 VMs, not 1.
Yeah.
Okay.
Which is a very good point, because a lot of people don't realize this. When you do disaster recovery or you scale things up, every time you scale it up, you're paying, like, if it was $50 for a VM and you scale up to 2, that's now $100. A lot of people don't realize that. They think they can scale up and scale down and it doesn't cost anything. But it's a good point that if you scale up the number of instances you pay times the number of instances, how much each instance costs. So that's an important point. Yeah.
Yeah, definitely. Because the best way to think about it is you have a compute resource that's running in their data center, and Microsoft, as great as they are, don't like to give things away for free. So yeah, as Greg has just said, if you scale it upwards or sideways, you'll pay for that compute time. So yeah, this is just a quick overview of what scale sets were and what availability sets were. Cool. Thank you, Gregor. Can we have, I think, my last slide, I think. So yeah, AVD, for those of you who are familiar with like managing RDS farms in the on-prem world, it's very much a similar style of management in terms of you have either your VDI deployment, so you can give every user an individual workstation, or you can have a traditional shared host model, and you can deploy and scale these farms en masse. And obviously using Azure, you don't have to manage or worry about the underlying infrastructure. You can just configure them based on how you want your workloads to run. They can scale up automatically and scale down based on times, workload, and all of that fun stuff.
So since we're switching slides anyway, Simon, can you name like a scenario where you would advise a customer to use Azure Virtual Desktop?
Yes. So a good example was over the pandemic, when everyone changed from working in offices to working at home, and some customers didn't have the VPN capabilities to support 200-300 people all dialing back into their on-premise environment. I saw a couple of instances around the community and in previous workplaces where we started to deploy AVD to be able to manage that workload, and it scaled really, really well.
Okay, cool. Thank you.
Okay, I think I have control now.
Just before you start, Matt, there's one question from Deep End saying, what type of workload will you use an Azure function for?
Yeah, I'll answer that if you want. Azure Functions. So before, well, let's start. Azure Functions are kind of like a function is a small bit of code that does one thing and one thing well. That's the definition of a function. So you might do things like sending out an email. That's always a good one. Sending out a PDF document. A kind of small bit of code that you run in an Azure function should run roughly in 5 minutes. So the idea is they want you to do a small bit of code quickly and efficiently. With Azure Functions, you get up to 1 million hits. You can call that function 1 million times in a month for free. So that's the beauty of Azure Functions. You can do small bits of code, repeat them a number of times for free for a month. They did bring out a thing called durable functions, which on top of Azure Functions means one function can call another function and you can store state. Because in Azure Functions, you can't store state, so you just need to do one thing that you throw away continually. And durable functions, function 1 can call function 2, and function 2 can read the state from function 1. So that's a way of chaining functions. But a good example would be maybe sending out PDFs for customer bills. That would be a good example that we've seen customers use for Azure Functions. Matt, go for it.
Okay. Thanks, Gregor. Yeah, so Simon has just covered off the various different types of compute that Azure offer, and I will just now go through how they can be used to host a web app, or the various different hosting options. So there are three primary types. So he touched on containers, which can be hosted in AKS or Azure Kubernetes Services. It also can be hosted in ACI and ACA. So ACI is Azure Container Instances, where you have a short running container that's a single unit that you want to run for a short amount of time, and then it shuts down. Azure Container Apps is a more recent addition to the Kubernetes container infrastructure, which allows for single containers for more kind of long running jobs. Kubernetes as a whole is quite a complex infrastructure. Microsoft takes some of that complexity away from you by hosting the control plane, so they look after hosting the manager nodes and all the management side of things, but you're still having to create containers and deploy them into Kubernetes or ACI or ACA. The beauty of containers is that it is the same code every single time. You create a container instance with a container which contains all the source code for your own applications alongside any dependencies. So if there's a specific version of Node.js or a specific version of Python that you need to be using, that can be built into the container. So when a developer is developing the application on their local machine, they're developing within a container. That container is exactly the same thing running in Azure. So it follows this workflow where you're building into a container and you get the same code every single time. It falls back to the concepts that Simon was talking around, pets versus cattle. So with containers, you treat them like cattle, and so if there's one that is poorly or ill, you just stop it and bring a new one up, and that is where sort of containers come into their own. Alongside containers, we have virtual machines, where Simon has gone through already. They are the more classic service for hosting websites. They give you the maximum flexibility because you choose the operating system, you choose the web server that you want to host, you choose any dependencies and any applications that you want to be running on that machine alongside your own code. It gives you that kind of precise configuration. It is the very sort of core infrastructure as service unit for Azure. But it does introduce its own overheads and issues, in that you are managing the operating system and the patching and everything that goes alongside it. So it is a very flexible choice, but it's also, there is a maintenance overhead alongside that. The other primary web app or hosting service for web applications are Azure Web Apps, or app service plans. So an app service plan is where it is effectively a virtual machine that is running. So it has a similar kind of compute stock keeping unit, or SKU, as Simon was mentioning. So you pick an amount of CPU power, an amount of memory that you want to be running behind your web apps. This could be used for Azure Web Apps, which are effectively IaaS services running in Azure, but they are also possible to use an app service plan to host Azure Functions, like Gregor just talked about. They are a very good platform generally for developers, because it removes the need for any of the hardware management and operating system management. You know, all you need to do is configure the web app itself to host your application. So you're specifying what language you're using, whether you want to use Linux or Windows to host it, and it gives the developer a strong foundation for their application. Microsoft and Azure look after all the patching and all the implementation of any kind of maintenance, so you don't have to worry about that at all. Within the web app service plan and web apps, that there's also options for scaling and high availability. So if you want to make sure that your web app is running all of the time, or at least minimizing any kind of disruption, you can ensure that it's running by having a version running in West Europe, but also a version running in North Europe, just in case something happens to the data center in West Europe where your machine, your web app is running. The app service plans and web apps can host a variety of different types of websites. Just the bog standard website front end. So what you'd see if you go to Microsoft's own websites, or Google, or the BBC. These are all just basic front end websites. They will also, you can also host APIs. So this is where it's more of a developer kind of interface for certain applications, where calls come into the website, but there's no web browser that's sort of driving the interaction with the web app. And then they can also support web jobs, which is more kind of a scheduled maintenance task or kind of upkeep task that you can run in the background. So this could literally be a small script or application that you deploy into your website alongside the other code to ensure the smooth running of your website day to day. So this is the three general options you have. You've got your basic virtual machine, which is your infrastructure as service offering. You've got your web apps and your app service plans, which is more your platform as a service offering. And then you've got the variety of different container offerings, which cross that boundary between infrastructure as service and platform as a service.
Matt, can I ask a question?
Yeah.
Could I host, if I wanted to move my blog off of WordPress, not even just WordPress, could I host my blog on Azure websites, for example?
Yes, yeah, you could host a blog on there quite easily. There's a variety of different ways you can go about hosting that. If the pages aren't dynamically generated or have any kind of complex code running behind it, you could even host it in something like a storage account, but that's kind of going into a little bit more kind of technical detail than is needed for the AZ-900. But yes, you could easily host a blog on an Azure web app, because that's what I'm doing. That's where my blog sits.
Where can we find your blog, Matt?
I'll pop it in the chat afterwards, because I can't quite remember if it's actually running.
Can I ask you one more question?
Mm-hmm.
So at what point would you say, like, let's say we have something running in a virtual machine, and at what point would you say it would be best to actually move that to AKS instead of having that in a virtual machine?
It really depends, I think, is the consultant's answer to that. The base issue would be what operating system they're running on, the complexity of the application. If it's a simple web app or web application, then you could containerize that quite easily. Containers are more of a service that lends themselves to a development framework called microservices, where each sort of little function has its own container in its own little world. So everything is split up. So if you have a gigantic single application that is running on a virtual machine, yes, you could put that into a container and you could run it in Kubernetes, but you would get no real added benefit over running it in a virtual machine, other than that you could scale up multiple versions of it quicker. It's so there's it goes on a case by case basis. I think is the best way to put it. But more modern development methodologies and sort of processes kind of lend themselves more to kind of microservices and Kubernetes. It's sort of over the last 5 or so years, it's been building a momentum as the de facto container hosting platform, but also containers are kind of becoming the de facto way developers create their applications. So it's easier to bring them into services like AKS, or you could host your own Kubernetes services if you so wish. It doesn't have to be a managed offering that Azure provide. There are people out there that will run their own versions. It just means that you're then paying for the virtual machines to run the management side of things as well.
Okay, sounds cool. Thank you.
Okay, perfect. Okay, so moving on to networking. So this is a slightly drier topic. So I've got a small demo, but it's a few more slides than what I've previously done. So networking covers a variety of different things, primarily Azure Virtual Networks, which within them contain subnets and the concept of peering. We'll also briefly talk about Azure DNS, Azure VPNs, and ExpressRoute. So these topics I'll cover in the next few slides. So the base element for all of Azure networking, and pretty much anything that you deploy into Azure that needs some kind of access to the internet, will use a virtual network or a VNET. These are isolated networks within Azure, so anything that gets put into a virtual network can talk to only the other resources within that VNet, potentially talking out to the internet if you so allow. You can put any kind of resource into a VNet, sort of from the web apps that we previously just discussed, to things like Azure SQL or Cosmos DB. So the VNets provide a way of communicating between each other. So this is peering, and it also gives you a way of connecting to Azure. So this is where the VPN Gateway comes in, and we'll talk about that later. Each VNet itself is an isolated network. It has its own address range. So this is the 10./16 address down here. So this is the address space of the whole virtual network. Within a virtual network, you can place your resources into a number of subnets. So a subnet is just a portion of the address space of the virtual network. The subnet itself comes with an additional security features called network security groups. And these are a way of restricting traffic in and out of a subnet. It's a way that you can kind of control what is happening to your resources and which resources can talk to each other. So you have this is the base unit for kind of controlling the communication between the various resources within Azure. So within a VNet, you have I think, did I miss a slide? No. So within a VNet, you can deploy services, and they can have either a public endpoint or a private endpoint. A public endpoint, as the name suggests, it's publicly accessible. So this is a resource that can get out to the internet, but also the internet can get to it. So most web apps or virtual machines that are hosting web services would have a public endpoint. Services more like your databases or Azure Functions potentially could sit behind, but within Azure and not have any public access. So if you're sat on the internet and you're trying to access these resources, you just can't get at them. So the public endpoint is accessible to anybody that has the correct credentials. This could be open to the internet just generally, or with authentication to ensure that only authorized people access those resources. And then the converse of public endpoints are private endpoints. These are endpoints that aren't accessible from the internet. So they might still be able to get out to the internet to download patches, to query things themselves, but they are protected within Azure. So the only way to access them is either through another resource in Azure or through a VPN gateway or similar kind of connectivity. Most of the time, the things that you're protecting this way are like databases and services that hold sensitive information. You know, in the most common kind of setup is that you would have a web front end that is running your code and querying things, but that's not where your data sits. Your data sits in a SQL Server or a Cosmos DB or even a storage account, or just something that removes it from the front edge of your network. So those are the two types of endpoints. You know, kind of, you might get asked the odd question on it. It's not a big part of the course, but it's something to be aware of, that there are these different types of endpoints that services can have. Okay, so quickly going over to the Azure portal, if I can get the right thing up. So going back to what Lisa was talking about with resource groups, this is a resource group I deployed earlier. It's called AZ-900 Networking. So this is me grouping logically all the resources for this demonstration. In here, I've got a virtual machine similar to what Simon has deployed already into his subscription. This virtual machine has an IP address and it is in a VNet. So because it's a virtual machine, it automatically deploys a VNet alongside the virtual machine. You can choose to put it into a pre-existing VNet if one doesn't exist, but for this demonstration, I just created a new one alongside it. This VNet, so the subnet on this VNet will have a security group alongside it. So in this VNet, you can see here's the address space. So this is the IP range that if you put more resources into this subscription, they would get an IP address within this range. In the subnet, there is just the one subnet because it's a basic VNet, and we have one device connected to this network, which is the network interface card, or NIC, for the VM. So it's a very basic networking kind of idea, the virtual network. Within it, you can look at within the virtual machine kind of configuration. You have access to networking configuration. Here, this VM that I've deployed is running IIS, so just a basic web server. But at the moment, if you try and access it, you get a site can't be reached because the network security group associated with this virtual machine is currently not allowing any communication from the internet. So it is currently in it is effectively a private endpoint. You know, that there is no way to get to this virtual machine from the public internet. But if we quickly give it access from anywhere to port 80, so the default HTTP port, this will take 30 seconds, but once that has been applied, we should hopefully then get to see the default page that is deployed when you initially set up IIS. So I'm just going to leave that there to sort of sit and think for a minute. But hopefully it will pop into life shortly. But so this is how you can control communication between subnets within the same VNet, but also between virtual networks. You could have virtual machines in different VNets, and you want to limit the communication between one virtual machine to another. This is a potential way of doing it. There we go. So this is now a public endpoint because anybody on the internet, if you go to that IP address, you will get the same response. Okay, so that's pretty much it from a demo point of view. So the one thing that was on a slide that has gone missing was the concept of VNet peering. So within a virtual network, it is an isolated region or an isolated address space. So the resources that you deploy into them can communicate with each other, but they can't communicate across different virtual networks unless you do a concept called peering. This is where as long as your address spaces don't clash, you can connect the two address spaces together, and it allows communication from one VNet to another. So sometimes when Gregor kind of alluded to it with the hub and spoke kind of configuration, it comes from networking where you have a central virtual network where your VPN gateway would potentially come into. And then you'd have separate VNets for possibly a test environment, a dev environment, a production environment, and you could segregate that traffic away from each other, but the hub VNet can communicate to them all through VNet peering. And it is a way that you can communicate between VNets in a kind of secure way because it uses Microsoft's backbone network, so it never truly goes back out onto the internet again. So you're going across Microsoft's own network to do that communication. So it's a more secure way of communicating between resources if needed. So moving on to the VPN gateway. So whilst you have all your resources sat in Azure, that's all well and good that they can talk to each other, but how do you talk to those resources if they've got private endpoints and they're not internet facing? This is where a virtual private network or VPN comes in, and Azure has a service called Azure VPN Gateway. This is where it allows a connection between two or more trusted networks to communicate. So these trusted networks could be completely different locations, and the only way to communicate with each other is over the internet. So you need to build an encrypted tunnel between these two trusted networks to ensure that any sensitive information doesn't fall into the wrong hands. So this is where the encrypted tunnels come in, and where virtual private networks come from. So it's not a new concept. Virtual private networks or VPNs have existed for many years. It's not a cloud-only technology. Many large organizations and corporations would have VPNs from one office to another to ensure various different offices could communicate without that information falling, sort of being exposed to the internet. So the VPN gateway for Azure manages the Azure end of your VPN connection. You need to configure a device at either end to enable the tunnel. So the VPN gateway is the Azure end of that tunnel. It sits in its own dedicated subnet. So you create a new subnet for the VPN gateway. It sits alongside your other resources. Doesn't really affect those resources. It just needs to sit there in a dedicated subnet. So it can run and not be disturbed by other things. There are two primary kind of types of VPN gateway that you can, or sort of VPN configuration that you can use: site to site and point to site. So as the names hopefully suggest, site to site is where you're connecting a site to Azure. So this is where you've got a office building or headquarters or branch office that you want to connect to Azure as a whole. So anybody that is sat within the corporate network of that office can access Azure without having to jump through any more hoops. They can just walk into the office, plug their laptop into the Wi-Fi or on an Ethernet cable, and they have access to the resources they need. It's a good way of securing an office to Azure connection, because you have one VPN appliance or firewall sat within that office doing that work to communicate with Azure to keep that VPN tunnel running. The other option is point to site. This is preferred for if you've got a distributed workforce. So if you don't have an office, or if your user base is spread across the world and they all work from their own homes, then having a site-to-site VPN is not correct for that. A point-to-site VPN allows a specific device to connect to Azure directly. This is because there's a client that sits on the machine that's configured with security certificates that will allow that connection. So you might have to authenticate through Azure Active Directory or put in a username and password as well, but that configuration sits on the machine. It's great for distributed workforces, but there's an additional overhead because each machine, whether it's done manually or through sort of group configuration management, needs to be configured to allow that communication to Azure. So without the VPN gateway running, it would just not allow either of these types of connections. Within one VNet, you can only have one VPN gateway deployed at any one time, but you can deploy multiple locations to connect to that gateway. So it doesn't have to be a 1-to-1 ratio. So you can have one VPN gateway that is running 2 or 3 site-to-site VPNs and point-to-site VPNs at the same time. It's just because of the way the networking works, you can only have one gateway sat in Azure. You can have multiple gateways in different VNets, as long as they're not talking to each other. You're not going to kind of run into too many issues. The VPN gateway itself, that there's 2 configuration options you have. So you have policy-based and route-based configurations. Route-based is the more preferred option because it's more resilient to changes in network configuration, because if your branch office suddenly grows and doubles in size and there's extra networks being brought online at that branch office, the routes are automatically pre-populated back into the VPN, so the VPN carries on working. The slightly older and less used configuration is policy-based, where the gateways have to be sort of reconfigured if there's a network change at either end. So it could be that all your changes are happening in Azure, and so you want to kind of keep the configurations fresh. Then I would stick with route-based, because that's where the resiliency comes in. So with VPN gateways, because it is a tunnel across the internet, it does become a single point of failure to some degree, because if it goes down, then your branch office or your users can't connect directly to Azure. So there are various different ways to make the VPN kind of highly available, so a bit more resilient to a single outage. By default, a VPN sits in an active standby setup. So this means that if the active connection fails for whatever reason, there is another connection that will pick it up. But there will be a couple of seconds to maybe a minute of downtime whilst that switchover happens. This is the default. So if you deploy a VPN with what looks like a single connection, there is a second set of resources sat there waiting. They're just in standby mode. Then they're not actively doing anything. This is done so if there's a planned maintenance, or if there's an outage within an Azure region, there is something to take over. But regardless of whether it's maintenance or outage, there is that little bit of a drop between one connection and the other connection taking over. So you might find that if your communication requires uptime, you need other options. And this is where active comes in. As the name suggests, both sets of resources are actively managing connections from on-site. You can also have multiple versions of your on-site VPN gateway appliance. So you could end up with effectively 4 tunnels across the internet from 2 devices on site to 2 devices in Azure, which, so if any one device goes offline, you've still got resiliency and redundancy between the connections. Because you have 2 separate active connections, these active connections do have separate IP addresses, so it's a bit more complicated and complex when it comes to configuring and ensuring your network flow is correct. But it's certainly something to consider if the VPN connection is vital to your communication. Something that we'll come on to in a minute is ExpressRoute, which is another type of VPN connection or connection into Azure. It has resiliency built in by design, but it still doesn't 100% guarantee an outage. So you could use something like a VPN gateway as an alternative connection method, just in case the primary circuits within your ExpressRoute fail for whatever reason, and then you have a backup kind of connectivity. As Simon mentioned with availability zones, you can also deploy VPN gateways in a zone redundant configuration. So this means that the different gateways that you're using are in distinct data centers within a region. So if for whatever reason a data center or availability zone gets knocked out, your other VPN gateway is completely unaffected, because it's in a different building with different network connections and different power, completely segregated away from that one availability zone. So it's a way of physically and logically segregating the 2 gateways apart from one another. So I briefly mentioned it in the last slide, but ExpressRoutes, it's an alternative way of connecting your on-premises networks to Azure. It does so over a dedicated private connection, but unlike the VPN gateway with a more standard VPN connection, the ExpressRoute doesn't go over the public internet. The connection is at a lower level within the networking stack. So the connection should be more reliable, it should be faster, and it should be secure. The ExpressRoute doesn't have to be just for Azure. You can use it for things like Dynamics or Microsoft 365. And you can also use it to connect different offices. So if you have an office in Europe and an office in Australia, you can have ExpressRoute connections into Azure, but your ExpressRoute connection in Europe is going to West Europe, and your ExpressRoute in Australia is going to Southwest Australia. You're then using Microsoft's backbone network to talk across the world effectively. That's a system called Global Reach, and it's a way of kind of connecting distributed offices to each other without going over the public internet. So it's another the kind of way of increasing security for your on-premises networks by utilizing some of the offerings from Azure. So, like I mentioned on the last slide, ExpressRoutes are built to be highly redundant, and this is because the providers of the ExpressRoutes use their devices in a highly available configuration. So there should be additional protection from loss of communication for anything traversing an ExpressRoute. So in the last few slides, we've talked about VNETs and subnets and how you communicate from your on-premise network to Azure. But one of the core ways that you actually communicate within, well, networking as a whole is DNS, or domain name services, or domain name system. So Azure has its own DNS called Azure DNS. It's a highly performant and scalable naming service. It's a way of converting a domain name, so something like google.com, into an IP address. So like the website I showed you previously, this IP address, it's quite hard to remember such an address, so you could use a domain name to make it easier to identify and communicate to various websites. So this is where DNS comes in. DNS within Azure is highly available and resilient. So as with everything that Microsoft offers, there is a core level of resiliency and availability. It's not a guarantee that there will never be an outage, but it's at least a way of ensuring that there should be minimal disruption if there is a problem. For Azure DNS, it's actually using Microsoft's own kind of global network of name servers, so it's not just in one region. It's a global service. And so when you query one of their DNS servers, you're generally querying the one closest to you. So if you have somebody in Singapore, they'd be talking to a DNS server in Southeast Asia, versus if you have somebody in America, they'd be talking to East US or West US. The benefits of using Azure DNS over other DNS servers out there is that if you're using other services within Azure, Azure DNS uses the same security features for protection. So the role-based access to protect changes, you can implement kind of resource locks, so that prevents accidental deletion or modification of your resource, your records in DNS, and means that your networking configuration and your name configuration sort of is locked down, so only a subset of people can change change things. So once you've got your name resolution working, so you're converting your domain names into IP addresses, how do you route things within the virtual network? So by default, Azure takes all of that on board and just uses its own default routing. So this is using either internal Azure DNS servers, or if you've got external DNS servers, it will use those as well. But it will route the traffic to where it thinks it should go, whether it be to another virtual network, to down a VPN tunnel to an on-premise network, or just out onto the internet. You can override this routing, however. So there is the concept of user-defined routes, where you create your own routing tables, and this is where you can suggest that rather than going straight out to the internet, you need to pass through a different virtual network first. This is getting slightly more complex and in-depth than you probably need for the Azure for the AZ-900, but it's something to be aware of, in that sort of within the networking framework, you could have an Azure firewall or something doing scanning and to ensure protection of your traffic in and out of Azure. And so there are times where you want to break away from the default routing that Azure offers, and to do this, you're using your route tables to create user-defined routes within your virtual networks. It just gives you that kind of greater control over where things should be. So, in summary, virtual networks, they're there for segregation and isolation of resources from each other and from the internet. There is a way of connecting the networks together as you need to. This is through VNET peering. The resources within a VNet or peered connection can communicate with each other, and the subnets with the network security groups and user-defined routes are a way of routing and filtering traffic as you see fit. For connectivity into Azure, you've got point-to-site VPNs, which is where you've got multiple laptops or desktops connecting to Azure from multiple locations. You've got the site-to-site VPN, which is a headquarters or office location connecting in through a firewall and a dedicated connection. Or you've got ExpressRoute, which is the step up from a site-to-site VPN that is communicating at a lower level in the networking stack, avoiding going across the public internet. All of this is supported by Azure DNS, which is the Azure hosted version of a domain name service for name resolution to resolve any kind of names to IP addresses, whether they be public or private. I think that's everything. Any questions?
Yeah, there was a question in chat by Carl saying, if we've got time, could you give a demonstration of assigning a DNS name to your public IPv4 address on your virtual machine?
Do we have time? I think
we're already quite a bit over time, but maybe if we wrap it up, and then we could show a demo if you have the time, and then the people that can want to leave or still want to ask questions, then they can do that first, and then we'll get to the demo later.
Yep. Okay.
Okay, let me share my screen again. Let's do that. Share screen. Okay. Right. Can you see me? All good?
Yes.
Okay, cool. Right. Okay. So if you could fill in that feedback form, that would be amazing. Our next session is in 2 weeks' time. Unfortunately, I'm not here next week. So we're going to give it a miss, and we'll finish the second part of part 2 in 2 weeks' time. We'll send out an email with all of the details and announcements, etc.
Yeah, so I think I'm sharing, unless my screen's showing something different.
Yes, you're sharing. Yep.
I can see it. Yeah.
Yeah. Okay. So I'm just going to use the DNS label that is optional within the IP address within the public IP. You can specify this through a DNS service, so you could create it with a completely different domain name and point it at this IP address, and it would resolve correctly. But I don't have a DNS zone set up, so I'm hoping this this will work and it isn't taken by somebody. So here I'm just creating a DNS label, so AZ networking, and it will then append it. So for where I've deployed this IP address, it's in West Europe, so it's applying a label to this IP address. So it'd be aznetworking.westeurope.cloudapp.azurenetwork.com. So if I just save that. Okay. And then you see here now it's saying that it's got a DNS name associated to it. And the VNet is still associated with the IP address. And it now has the same DNS name associated with it. So if I get my other web browser up, theoretically, this name is now resolving to exactly the same place that this IP address was. So that's a brief introduction to sort of domain name kind of configuration within Azure with
awesome.
the default options.
Awesome. Thank you for that. Okay, just last but not least, we're back on the 25th, and once again, thank you all for joining. Please do fill in the feedback though. Thanks everyone.
Thank you.
Take care. See you in a couple of weeks.
Bye bye.